Mhm. So what's the issue? Is there a connection issue or something? Or can you hear me? Is there an issue with my connection or anything? Please give me a second. Hello, can you hear me first of all? Number 16, number 155. Is there a problem with our connections or something? Okay, so then please answer me. Let me know where we stopped last time. Did we discuss about limiters? Yes. Is it? So I gave you a question. Okay. So can you tell me what was the question? Forward. Okay, so the question was actually to design a circuit to. Okay, I think I wanted you to design a circuit to get output like this, something like this. Okay. So I wanted to limit the voltage from both sides, the positive and negative. Both voltages I need to limit. Okay, at point 7. Yeah, something like this. Something like this. This is plus 0.7. This is minus 0.7 volt. Okay. So did anyone make the circuit? Okay. So you can try. Okay. So I won't give you the answer. Try to find out. Okay. So there are some questions you can. Okay. Right. Now let's look at a bias limiter. Okay. Right. So let me draw a new circuit. So this, yes, maybe. Okay, let's take the limiter circuit, the same circuit, and I'm going to fix a small battery. Okay. And I have the load, right? So can you tell me how does the output look like? So let's say it's a 1 volt battery. Let's say the forward bias voltage of this diode is 0.7 volts. Okay. We have two resistors, it's the R1 and RL. So how should the output look like? So let's say this is the input. Then what about the output? Can you tell me how should the output look? Not sure. Is it? Yes. Well, the answer is given in here. So what's going to happen is, so when you okay, let me draw it in here to make it a bit more clear. Let's say this is the input voltage. Okay. So when you give a positive voltage, the positive voltage will apply across this diode. Okay. So usually, so if you don't have this guy, then when the positive voltage is greater than 0.7 volts, this circuit will become a short circuit. This line will become a short circuit, and okay, so and the signal will this voltage will appear across this resistor because this is going to be short circuit. Right? So if we don't have this battery in here, then circuit will be something like this. This will be a short circuit. Okay. We have the positive voltage applied here. So because this is short circuit, only the diode drop will appear across this voltage, this resistor, right? Load resistor. So you will have something like this, 0.7 volts, and the negative half will appear across the diode because it will be an open circuit for the negative half cycle. Okay, right. And now we have this extra battery. Then what do you think should happen? If you can think as that, Right. So what should happen? Well, so in the previous case, the barrier voltage was just 0.7 volts, right? Just 0.7 volts. But now we have 0.7 plus this battery, right? So to make this diode forward biased, okay, so that, okay, let me maybe clarify it a little bit. So it's like this. So we have a diode like this, right? So, sorry. So to forward bias a diode, the voltage difference between the two ends of the diode should be 0.7 volts, right? So if this voltage at this side is 0.7, if the voltage at this side is 0 volts, then the difference, right? 0.7 minus 0 is equal to 0.7 volts. Okay, this should be satisfied, right? Okay, but in this case, now this voltage at the cathode side is actually not 0, right? Now it's 1 volt. Okay. It's 1 volt. Okay, right. So can someone tell me the minimum voltage we should apply at this end to make this diode forward biased? Yes, that's the question. Think and give me answer. Right. So the question was what we should apply. VA minus VB, right? What is difference? So what's the difference? VA is 0.7, okay? VB is 1 volt, right? So 0.7 minus 1 is minus 0.3 volts. It's not 0.7, right? So we have to increase. So shall we make this 1 volt and see? Let's make this 1 volt. Now what? Apply. Now you can see, right? What do you think? What's the voltage we should apply to get this difference between the across the diode? Yes. Okay. Okay. Sorry. Did I was the mic mute all the time? Oh, I just muted it. So, did you hear what I told just now in the last within the last 2 minutes? The mic muted? Yes or no? Did you hear what I said about this voltage? We don't have much time, so number 16. Can you speak? Are you guys there, by the way? What's wrong today? Hello, can you hear me? Why no one is answering or responding? Okay. Well, it's very difficult when you don't respond, actually. What can I do? What should I do? What's the problem today? Are you guys there, first of all? Number 16 and number 155. Are you guys there or not? Please answer. Okay. Okay, is there a connection issue or something? So if you have some issue, please let me know. Is there a signal issue? So number 15 just dropped. Okay, let me give a small message. So between 2 and 3 today, come and meet me. Okay, I'll be in the GF1 lab. So all the students come and meet me. Okay, I need to speak to you a little bit. Okay, physically come and meet me at GF1. Did you get the message? Can you hear me, first of all? So only once, only number 16 is there now. Number 16, can you hear me? Hello. Okay. So please come and meet me at GF1, okay, with others. Give them the message. Right. So I don't know whether you heard whether you heard what I said or not. Explain this part again. So to forward bias this diode, we have to apply the voltage across the diode. So the voltage difference should be 0.7 volts, right? If I apply, let's say 0 volts, 1 volt at the point A, then the voltage difference is going to be VA minus VB, which is in this case 0.7 minus 0.3 volts, right? So let's change the voltage. Is going to be how much? 0. Still is 0.7. Now you can ask 0.7, then 0. You're not in the campus today. That case, or is this but is the clamp. Clamp will clamp the voltage at a different level. Okay, clamp. So if this is the input voltage, then the output will be clamped. Okay. Something like this. This is zero clamp. Okay. Clamp. Okay. So you can set this value. Okay, to 1 volt or something. So how is that going to happen with this circuit? So let's see. When we give a negative voltage in the negative cycle, what's going to happen? So when we give a negative voltage, okay, so okay, so it's like this, right? A negative voltage means we are applying a positive voltage to this side and a negative voltage to the other side, right? So it's a negative voltage. So the current will so if this when this voltage is greater than 0.7 volts, this diode will get forward biased, okay, and a current will flow in this direction and will charge the capacitor. Okay, so the capacitor will charge up to this much, right? The peak voltage, okay, of the input voltage wave minus 0.7 volts, right? Like this. Okay, right. So that's during the negative cycle, okay. Then that's for the negative cycle. Then what about the positive cycle? So when you apply a positive voltage, means you are applying a positive voltage from this side and a negative voltage from this side. So now this capacitor can actually it's like a battery, a DC battery, okay, with a fixed positive voltage. Okay, so the capacitor is now actually it's like a battery, right? And so this new the voltage of the voltage source is now going to add to this value. Okay, so it's something like this. So the diode in that case will get reverse bias, right? So this connection will be an open circuit, and all these voltages will appear across the load, right? So this is the fixed voltage, because this is the sine wave, right? So if this is, for example, 1 volt, the voltage of the capacitor, then the output will be 1 volt plus the sine wave, right? So that during the negative half cycle, you will have this 1 volt, okay, plus the sine wave on top of, right? Something like this, okay, during the negative half cycle, okay, during the negative, sorry, yeah, during the negative half cycle, you will have uh, mm, sorry, yeah, something like this, right? So this is during the positive half cycle, okay. So during the positive half cycle, we will have something like this. The capacitor voltage plus the sine wave, the value of the sine wave. Okay. And then during the negative half, what's going to happen? During the negative half, this will be short circuited. So the capacitor will get charged. Yes, what do you think? It's going to happen. Well, the capacitor is already charged, right? So the capacitor voltage will be there. Okay. And okay, during the negative half cycle, so during the negative half cycle, okay, the capacitor voltage will be there because the capacitor is already charged, right? And the negative voltage is still trying to charge the capacitor. Okay. And this AC voltage, so this voltage will appear across the resistor, okay? And okay, so because we have a fixed DC voltage in here, the diode won't get forward bias, right? This, okay, so right? Because we have this much of a voltage at this point, right? So the diode will be reverse biased until the input voltage gets equal to this value. Okay? So as a result, this terminal will still act like an open circuit, and this negative voltage will appear across the load resistance. Okay, something like that. So as a result, we will get this clamped output. So we call it clamp, a diode clamp. Okay. Right. By the way, we will have the mid exam within next 2 weeks. Okay, within either next. So I will let you know within the next week or in the probably in the week after that. Okay, we will have your mid exams. So you have to study everything on diodes. Okay. Okay, so today I have to stop the lecture a little bit earlier, so we will continue next week. And I need to make a couple of extra lectures as well. Okay. So after we meet tomorrow, so let's discuss. So I need to fix a time. Well, to catch up, I need to fix some extra lectures and do some catch-up timing, and also we need to finalize your practicals. Okay, you didn't come for the practicals on Wednesday, right? Why was that? Anyway, we'll discuss tomorrow. Okay, let me know. Okay, so make sure to meet me tomorrow. Okay, right? Anything you want to know?